So now for a couple of relevant examples of the root test, we're going to consider the following two situations. We're going to do the sum from n equals 1 to infinity of negative 2 raised to the nth power over n raised to the nth power. Now, as a reminder, the expression that we want to set up is the limit as n goes to infinity of the nth root of the absolute value of a sub n. So in this case, that would be the limit as n goes to infinity of the nth root of the absolute value of negative 2 to the n over n to the n. Now, sticking with the order of operations on this, we'll apply the absolute value to these things first. N is already going to be a positive quantity since we started at n equals 1, and n simply goes up from there. As a result, when we take the absolute value of everything that's inside here, it'll cancel out the negative portion, and we'll have 2 to the n over n to the n. Now, because everything is already raised to an nth power, the nth root is simply going to cancel out the nth power, telling us that the 2 to the n will become 2, and n to the n will become n. This limit is equal to 0. Your numerator is finite, your denominator becomes infinite, that approaches 0. Now, the important thing about 0 is that 0 is less than 1. As a result, we can draw the following conclusion. Therefore, by the root test, the series sum from n equals 1 to infinity of negative 2 to the nth power over n to the nth power absolutely converges, or converges absolutely. For another example of the root test, and another example of a variable raised to a variable power, we have the sum from n equals 0 to infinity of the arctangent of n raised to the nth power. That nth power lets us know that it's going to be a good idea to use the root test. So once again, we'll be setting up the limit as n goes to infinity of the nth root of the absolute value of a sub n. Setting up this expression will be the limit as n goes to infinity of the nth root of the absolute value of the arctangent of n raised to the nth power. The absolute value in this case is going to do absolutely nothing. Bad pun, sorry. This is due to the fact that the values of n will be non-negative, and therefore the arctangent will be non-negative as well, meaning that the absolute values won't actually do anything. This will give us the limit as n goes to infinity of the nth root of, we don't need to worry about the absolute value bars anymore. Once you have an nth root applied to an nth power, those will simply cancel each other out. We'll be left with the limit as n goes to infinity of the arctangent of n. This is a limit that exists and is equal to pi over 2. Now, pi is about 3.14, 15926535897932384626433, and dividing that by 2 is going to result in a number that is slightly bigger than 1, about 1.57 or so. Now, with that in mind, because we got from the root test that this is greater than 1, we are allowed to draw a conclusion. Therefore, by the root test, the series sum from n equals 0 to infinity of the arctangent of n raised to the nth power diverges. So do keep in mind, anytime everything is raised to an nth power, that is a great time to be making use of the root test.